misstep can have huge consequences. Okay, let's dive into this incredible world of acid-base balance. It really all comes down to this one number, 7.4. Seriously, this is the magic pH your blood absolutely needs to be for you to stay alive. And the margin for error? Oh, it's razor thin. We're talking a tiny, tiny range between 7.35 and 7.45. If you stray outside that, your body's entire metabolic engine just starts to seize up. So how in the world does our body pull off this incredible feat? Well, here's the game plan for this explainer. First, we'll see why this balance is so darn critical. Then, we'll decode the basic chemistry and check out the body's amazing built-in defense systems. We'll also look at what happens when things go wrong, the domino effect of acidosis, and finally, how we can get back to that perfect harmony. Right, so let's start with that perfect balance. And it's no exaggeration to say we're talking about life on a chemical knife's edge. Our very existence really depends on keeping things within that incredibly tight pH window. And believe me, that range is totally non-negotiable. Why? Well, because pretty much every single vital process, from how your enzymes work to how your muscles contract and nerves fire, is fine-tuned to work perfectly, but only within this specific pH. It's the essential environment that makes our life possible. Okay, to really get this, we've got to meet the key players. But don't worry, this isn't going to be some deep dive into a chemistry textbook. We're just going to take a quick look at the essentials: acids, bases, pH, and the body's secret weapon, buffers. First up, we've got acids. So what's an acid? It's simply a substance that gives away or donates hydrogen ions. That's the H+ there. They're just a natural byproduct of being alive, and our body is constantly working to keep them in check. And the perfect partner to an acid is a base. Its whole job is to accept or soak up those extra hydrogen ions. It neutralizes their acidic effect. It's a beautiful chemical partnership, really. So where does pH fit into all this? Think of it like a report card. It's just a scale that measures how many of those hydrogen ions are floating around. A low pH means things are more acidic, and a high pH means things are more basic or alkaline. Simple as that. And now for the real hero of our story, the buffer. The best way to think of a buffer is as a chemical sponge. Its entire job is to soak up excess hydrogen ions, to stop those wild, dangerous swings in pH from happening. And this is the brilliant way buffers work. They take a really dangerous, strong acid, which is like a fire hose dumping all its hydrogen ions at once, and they cleverly convert it into a weak acid, which releases its ions much more reluctantly. It's like turning that fire hose into a manageable little trickle. So this all comes together in something with a very complicated name, the Henderson-Hasselbalch balance. But forget the name. The concept is as simple as a seesaw. On one side, you have your main base, which is bicarbonate, and on the other, you have your main acid source, which comes from carbon dioxide. The body's entire mission 24/7 is to keep this seesaw perfectly level to hold that magic pH of 7.4. So how exactly does the body keep that seesaw so perfectly level? Well, it doesn't just cross its fingers and hope for the best. It's got these incredibly sophisticated, multi-layered defense systems that are always fighting to maintain that perfect balance. The kidneys are the real master regulators here, and they have this amazing two-step strategy. Step 1 is just daily maintenance, constantly reclaiming and recycling those buffer sponges. But step 2, that's the emergency response. When things get too acidic, they kick into high gear and actively generate brand new bicarbonate to fight back. And the kidneys aren't working alone. They've got a whole team. Hemoglobin in your red blood cells, that acts as a buffer. Special buffers in your urine, they're critical for that emergency bicarbonate generation. Even cells in your stomach can lend a hand under certain circumstances. It's a full-on team effort. But what happens when these incredible defense systems get overwhelmed? Well, this is when that balance tips into the danger zones. Acidosis, where the body gets too acidic, and alkalosis, where it gets too basic. This little grid makes it all super easy to understand. The problem can either be metabolic, meaning it's an issue with your bicarbonate, or respiratory, an issue with carbon dioxide. If your pH drops below 735, you're in acidosis. If it climbs above 745, it's alkalosis. You just combine those and you get the 4 main disorders. Let's go back to our seesaw analogy because it makes this crystal clear. Acidosis happens when the seesaw tips toward the acid side. This is caused by one of two things. Either you lose your base, the bicarbonate, or you gain too much acid from CO2. And alkalosis? It's the exact opposite. It's really all about which side of that seesaw is being weighed down. Okay, so now we're going to focus in on acidosis, mainly because it's way more common. And you have to understand it isn't just a bad number on a lab test. It's a systemic problem that kicks off a dangerous domino effect through your entire body. And the first dominoes to fall are often the most critical ones. Acidosis directly messes with the heart's ability to pump blood effectively. And at the exact same time, it's hitting the central nervous system, which can lead to confusion, exhaustion, and in severe cases, even a coma. And the effects? Well, they get even more complicated. Take oxygen delivery. At first, a more acidic environment actually helps your red blood cells release oxygen to your tissues. It's a weird quirk. But if that acidosis sticks around, the effect flips, and it starts starving them of oxygen instead. What's even scarier is what it does to potassium. As those hydrogen ions rush into your cells to get buffered, they force potassium ions out into the bloodstream, leading to dangerously high potassium levels that can affect your heart. The damage doesn't even stop there. Those hydrogen ions also play bumper cars with calcium, knocking it off of proteins and messing up your body's calcium balance. And over the long haul, with chronic acidosis, the body literally starts dissolving bone tissue to use as a buffer for the acid. I mean, it leads to your bones getting significantly weaker over time. So after all that doom and gloom, how do we fix it? Well, the goal is always to restore that delicate bodily harmony. And that involves both quick medical intervention and, of course, supporting the body's own amazing ability to bounce back. In any emergency like this, the first steps are always the same. You treat the patient, not the number on the lab report. It's the ABCs: secure the airway, support their breathing to help blow off that extra CO2, and stabilize their circulation. Only when the patient is stable can you really start to effectively treat what caused the acidosis in the first place. It's just incredible, isn't it? Our bodies are constantly performing this ridiculously complex and vital balancing act, all without us even knowing it. It really makes you stop and wonder, what other hidden, intricate systems are working tirelessly right now just to keep you alive?